Okay, this is a video that goes over the questions in the study guide. See the file along with the file that has the questions along with this study guide. I'm going to focus mainly on using StatCrunch to answer most of the questions that can be done using StatCrunch. There are some questions you cannot do using StatCrunch. You just have to do manually or visually by looking at the question, but any question that has to do with finding probability or constructing a confidence interval, we'll do it using StatCrunch. Number one, determine whether the graph can represent a normal distribution, normal curve. You know that this one cannot represent a normal curve because a normal curve supposed to be bell-shaped, and it does not start at zero. This one looks like it does start at zero. A normal curve has two tails that extends indefinitely, one to the right and one to the left. Number two, the weight of 2-year-old hyraxes is known to be normally distributed with the mean of 2,200 grams and a standard deviation of 365. Draw a normal curve. So I'm going to show you how we can do that using StatCrunch. So you go to calculators, normal calculator, mean is 2,200, just to show you how the distribution, the bell-shaped curve will look like, and the standard deviation 365. If you hit compute, okay, we have to put some number there. I'm just gonna put any numbers and ignore the red shaded region, but this is what the normal curve would be like. So more than 2930, just greater than 2930. And he doesn't want the answer, just wanted to shade it. But no, this is the this number right here is 2930, and that's the answer, actually 0.0228 if he asks you to find the probability. Next question. The SAT is an exam used by college and university to evaluate undergrad applicants. The test scores are normally distributed. In a recent year, the mean was 1,475 and a standard deviation of 308. The test score of 4 students selected at random are the following. Find the z-score. The formula for the z-score is z-score equal value minus mean divided by standard deviation. So for example, if you take 1930 and you find the z-score, it will be 1930 minus the mean, which is 1475, and then divide by the standard deviation, which is 308. To do the second one will be 1340 minus 1475 divided by 308, and so on and so forth. For part B, determine whether any of the values are unusual. If one of the value is more than 2, guys, or less than -2, then you can say that this value is unusual. If all the values are between -2 and 2, then none of them are unusual. They are usual values. Number 4, find the area of the indicated region under the standard normal curve. Since there is a 0 in the center, so this is about z. So he wants you to find the probability of z between -0.45 and 2.11. We can easily use StatCrunch for this one, and let me show you how. So you go in between right here, -0.45, 2.11, and 0.1. This is the standard normal curve, and compute and you get the area, which is 0.6562. Find the area under the standard normal curve to the left of z equal 1.5. Here's how we do this one. We'll go back to StatCrunch. Okay, go back to standard. To the left means less than, and 1.5 is the z value, the z, and then hit compute. It's 0.9332. Next question. Find the area under the standard normal curve to the left of 1.25. Exactly the same thing as I did number 5, but change 1.5 to 1.25. Number 7, find the probability of z between 0 and 2.25. It's very much the same as number 4, but I'm gonna do it. So let me show you. Just go between and change it to 0 and 2.25. Hit compute, and here is the area. Not only it gives you the answer, but it changed the region as well. Okay, for number 8, the distribution of cholesterol levels in teenage boys is approximately normal with 170 mean and standard deviation theory. Levels above 200 warrant attention. I'm going to reword this question in 2 parts. First part, if one teenage boy is selected at random, what's the probability that he has a cholesterol level more than 225? So we're going to go to StatCrunch and try to do this one. So the mean is 170. It's not 0.1 anymore now. Standard deviation is 30. And go to standard, click right here. And he wants what's the probability that the cholesterol level is greater than, what was it? Let me double check. More than 225. Here you go. So this is the probability. It's 0.0338. Now the next question. If 95 teenage boys are examined, how many of them would you expect to have a cholesterol level more than 225? Since you already have found the probability, which is 0.033, multiplied by 95, and that will give you a number of teenage boys. It's going to be about 3 point something. You just round it, and it will be 3 boys. Number 9. Find the area under the standard normal curve to the right of z equal 1. Once we go back to z, it's 0, 1. Mean is 0, and standard deviation is 1. So I'm going to take you back to standard. 0 and 1. And to the right means greater than. So just put 1 here, compute, and that's, you see, the area shaded to the right of z equal 1. So what we did makes sense. Is 0.1586. Next question. Number 10, find the area under the standard normal curve between z equal negative 1.5 and 2.5. We did quite a bit of those already. Between, it just choose between. Negative 1.5 again, 2.5, and hit compute, and here you go. That's the area. Next question, guys, exactly like number 10. Between z equals 0.3 and 1.4. Just do exactly like I did in 10. Number 12, assume that the random variable x is normally distributed with a mean of 60 and standard deviation of 16. What's the probability of x less than 80? So now he gives you a mean and standard deviation. You don't use 0, 1 anymore. So we're going to go back to StatCrunch and show you how to do this one. So we change the mean to 60, standard deviation to 16. We go to standard, and he wants the probability of x more than 80. That's the answer. More than, and 0.056. Okay. My apology, I did more than 80, but the question is for x less than 80, probability of x less than 80. So we can easily do it. Look right here. Less than 80, compute. That's the answer. All right. Number 13, a physical fitness association is including the mile run in its secondary school fitness. The time for this event for boys in secondary school is known to possess normal distribution, with a mean of 450 and a standard deviation of 50. What's the probability randomly selected boy can run the mile in less than 335 seconds? very similar to number 12. So I'm going to show you how to do that in StatCrunch. 450 for the mean, 50 for the standard deviation, less than 335, and you get the answer. There you go. 0.0107. That is the probability. Probability of x less than 335 equals 0.0107. The next question. The length of time it takes a college students to find a parking spot in the library follow a normal distribution with mean of 6.5 and standard deviation of 1 minute. What's the probability randomly selected college students will take between 5 and 7.5 minutes to find a parking spot? Okay, we'll go back to the normal calculator instead. Crunch. So it's 6.5 is the mean. Standard deviation is 1, and we go to between. 5.5. Is it 5 or 5.5? I'll check. And 7.5 minutes, and hit compute. So that would be the probability. If it is 5 and 7.5, let me just double check. Yeah, that is correct. Number 15, a firm believes that the internal rate of return for its proposed investment can be best described by a normal distribution with a mean of 36% and standard deviation of 3%. What's the probability that the internal rate of return from the investment exceed 42%? Exceeds means more. So we'll just go to StatCrunch and do it right there. You got the mean, you got the standard deviation, and you need a probability of x more than 42. 36, 3%. You can change him to decimal, or you can leave him like that as percent. That would be okay. And that's greater than, and put the 42 right here. And hit enter, and that's the answer. Next question. Find the z-score for which the area under the standard normal curve to its left is 0.04. Now, guys, he's given us probabilities, and he wants to go backward and find x or z. So we're going to be using the normal calculator still to do the remaining all the problems here. So we have the area to the left, which is 0.04, and he wants the z-score. Here's how you do it. We go to StatCrunch. So since it's about z, we'll just go back to 0.1. And he gives me the area, which is 0.04. Look where I'm putting the area, right here on the right, because this is where the probability end up being at, in this field box right there. And since it is to the left, I need to make this less than, and that would be the z-score. It's negative 1.75. So we write z equal negative 1.75. Next question. Find the z-score for which the area to the center to its right is 0.07. Okay, here's what we're gonna do. So because we're gonna put 0.07 here, and to its right, you have to make it greater than, and it's gonna give you the z-score, which is 1.48. Okay. 18. Determine the two z-scores that separates the middle 87.4% of the distribution from the area in the tails of the standard normal distribution. Again, he's talking about standard normal curve z-score 0.1. He wants the two z-scores that separates the middle 87.4% of the distribution. Okay, here's how we do this one. Go between, because it's middle, and put here 87.4%, which is 0.874. Hit compute, and you're gonna get the two z-scores. One is negative right here, and one is positive right there. So the answer will be z equal negative 1.53 and z equal 1.53. 19. Assume that the random variable x is normally distributed with the mean of 50 and standard deviation is 12. So no more 0, 1 now. He's giving me the mean and standard deviation. What is the 24th percentile for x? So he wants the x value at the 24th percentile. At 24th percentile is an area to the left, so it's 0.24. Here's how you do it. Just go back to StatCrunch. Okay, we go to standard, and I forgot what the mean was and standard deviation. The mean was 50 and the standard deviation is 12. So 50, 12, area to the left, I have to do less than, and I have to put the 0.24 right here. This is the percentile. Remember, guys, this field is for the probability and this field is for the x value. Now he's given us the probability, so we have to put him here on the right to get an answer on the left. 41.52, that would be the x value. Next question. 20. Physical Fitness Association is including the mile run in secondary school fitness. The time for this event for boys in secondary school is known to possess a normal distribution with the mean of 440 and a standard deviation of 50. The Fitness Association wants to recognize the fastest 10% of the boys with certificates of recognition. What time would the boys need to beat in order to earn the certificate? Now you have to remember, guys, fastest 10%, it doesn't mean that this is an area to the right, because you will finish, just fast if that means the time, it takes you to finish fast is less than the others. So people who finish fast, they finish in less time. So the 10% here, a lot of students interpret this as a top 10% and you put an area to the right. No, for races, the lesser the time, the better. So the 10% is going to be an area to the left. And here's how we deal with it in StatCrunch to find the x value. So put the mean, which is 440, put the standard deviation, which is 50, and do less than here, and come here and put the 0.10, the 10%. Excuse me. Compute. So anyone who finish in 376 seconds or less will receive a recognition certificate. Yeah, definitely not the ones, just who finish toward, the very end. The average time to finish this race is 440. So if you can do below average as far as the time it takes to finish the race, then the better, not above average in this case. All right, so next question. Assume the salaries of elementary teachers in the United States are normally distributed with a mean of 37,000 and a standard deviation of 5,000. What's the cutoff salary for teacher at the bottom 10%? Bottom 10% means the lowest salaries. Yes, it's going to be an area to the left in this case. So we have the mean 37 and standard deviation is 5,000. So 37,000, 5,000, and area at the bottom 10% is going to be here, 0.10. And notice, guys, as I start typing in this box, this becomes empty and ready, just to populate in a second. So any teacher who receive a salary of 30,592 or less are considered bottom 10%. Next question. Remember, determine mean of x bar and sigma of x bar. The bar should be on top of x here. From the given parameter of the population and the sample size, round the answers to the nearest thousands where appropriate. Remember, the central limit theorem tells us when we work with samples from a population that is normally distributed, the mean of the population will be the mean of the sample mean. So mean of x bar, guys, is going to be 28. But the standard deviation of the sample means will not be 8 again. It will be 8 divided by square root of 22. That's what the central limit theorem says. So you're going to do 8 divided by square root of 22 to find the standard deviation. Okay, next question. What are the value of the mean and the standard deviation of this sampling distribution? This x right here should have a bar on top of it, guys. Should be x bar. This is for the sample mean. As we said in the previous question, the mean is the mean. So the mean of x bar will be 8. And the standard deviation, guys, how much are we jumping from this point to the other one? We're jumping 0.04, though, so standard deviation will be 0.04. Number 25. The number of violent crimes committed in a day possesses a distribution with the mean of 2.2 crimes and a standard deviation of 6 crimes per day. So the mean is 2.2 and the standard deviation is 6. A random sample of 100 days was observed, so n is 100 here. And the mean number of crimes for the sample was calculated. Describe the sampling distribution. As we mentioned, the central limit theorem tells us that the distribution of the sample means is also bell-shaped, is also normally distributed, is also normal. And he tells us that the mean of the sample means will be the same as the original mean. So your answer is going to be mean of x bar, this one, equals 2.2. But the standard deviation, guys, is not going to be 6. It's going to be 6 divided by square root of 100. If you take 6 and divide it by square root of 100, you will get 0.6. 26. Exactly, guys. You do the same thing. He didn't ask the question here, but the question is to find the mean and the standard deviation of the sample means. The mean will be 5.4 of x bar, and the standard deviation will be 2.1 divided by square root of 12. And the distribution of the samples, guys, will also be approximately normal. It will look bell-shaped as well. 27. Assume that the salaries of elementary school teachers in the United States are normally distributed with the mean of 32,000 and a standard deviation of 3,000. If 100 teachers are selected at random, so now the question, guys, is not about x, it's about the mean, x bar. If 100 teachers are randomly selected, find the probability that their mean salary is greater than 32,500. Before we do this, before we go to StatCrunch and use the normal calculator, you have to calculate the new standard deviation. So guys, before we go to the normal calculator, we need to calculate the new standard deviation. When you work with samples, you cannot use the original standard deviation. You have to use this one right here that I just shaded. So it's 3,000 divided by square root of 100, which will be 3,000 divided by 10, which is 300. So when I use StatCrunch, I have to enter 300, not 3,000. So the mean is 32,000. The sigma of x bar is 300, and we need to find what's the probability that x bar, not x, is greater than 32,500. So 32,000, sorry, 300 greater than 32,500. Actually, if I could change this x, I could change it and put the bar on top of it, but you know, this program doesn't allow me to do anything here. So, and then hit compute, and that's the answer. Next question. The average score of all golfers for a particular course has a mean of 75 and a standard deviation of 4.5. So the mean is 75 and standard deviation 4.5. Suppose 81 golfers, so n is 81. We're working with a sample now. Played the course today. What's the probability that their mean score of the 81 golfers exceeds 76? So this is a question about the average, about the mean. We need x bar, so probability of x bar greater than 76. When we use the normal calculator, we use the same mean, which is 75, but we cannot use the same standard deviation. So the new standard deviation, guys, is going to be 4.5 divided by square root of 81. Square root of 81 is 9, so you'll get 0.5. So we need probability of x bar bigger than 76 using a mean of 75 and a standard deviation of 0.5. This is 76. And again, this should be a bar here, but you cannot change this one, this screen. So it's 0.0228. That would be the answer. Okay. 29. The amount of money collected by a snack bar at large university has been recorded daily for the past 5 years. Records indicate that the mean daily amount collected is 4,000 and standard deviation is 450. The distribution is skewed to the right. So the original population is not bell-shaped. It's skewed to the right due to several high-volume days. Suppose that 100 days were randomly selected from 5 years and the average amount collected from those days was recorded. Which of the following describes the sampling distribution? So he's asking us to describe the sampling distribution of the sample means. The original population is not the normal, but the sample size is more than 30, it's high. So then you can make an assumption that the distribution of the sample means is going to look bell-shaped, it's going to be normal. The mean will be the same as the original mean, which is 4,000, but the standard deviation, guys, will not be 450. It will be 450 divided by square root of 100. And what is square root of 100 is 10. So it will be 450 divided by 10, which is 45. So if this was a multiple choice question, you will select this answer. The distribution of the sample means is normal. The mean is 4,000 and the standard deviation is 45. Next question. The length of pregnancies are normally distributed with a mean of 264 days and a standard deviation of 15. If 36 women are randomly selected, what's the probability that they have a mean pregnancy between 264 and 266? Remember, guys, he's asking you about the probability of the mean. It's a probability of X bar. So we're going to be using the mean of 264, but the standard deviation won't be 15. It has to be 15 divided by square root of 36, just like I did with 27 and 28. What is 15 divided by 30 square root of 36? It's 2.5. So we're going to go to StatCrunch. We're going to input 264 and 2.5. And then we have to find the probability of X bar between 264 and 266. $264. There you go. That's the answer. When do you keep the standard deviation is 15 the same? If he asks you about one individual, if he doesn't ask you about a group, about a sample. If it is about one person, the same standard deviation. We use the original standard deviation. But when it comes to a sample, you have to use the standard deviation given to you divided by square root of the sample size. So this is the first part of the video that covers normal distribution, how to compute probabilities, normal probabilities, and the central limit theorem. The second part of the video will be about estimation and confidence intervals.